All right, we're on 1.4 notes. It ties into our SOHCAHTOA quite a bit. So there's a lot of sine, cosine, tangent. We're going to start with a coordinate. This coordinate right here of negative 3, 4. So I'm going to bring this, move it up a little bit here so we can see this. And we're going to let negative 3, 4 be a point on the terminal side, meaning the ending side of our angle. So we're going to graph that point. Let's go over negative 3 and up 4 and make a dot there. And then use your ID card or your planner or something straight where you have a straight line. And draw a straight line from the origin and then have it go through that point. And then draw a line on the x-axis so you can see where the angle would be. Make your arrows here. And this right here we're going to call theta. That's our cursive O, our theta. So it says point negative 3, 4 is on the terminal side, the ending side of my angle. My angle starts at the x-axis, and then it goes to this line right here, and the point negative 3, 4 is on that line. They want us to find the sine, cosine, and tangent of theta. Now, right now, the way it's set up, theta is obtuse. So we can't actually find a sine, cosine, and tangent when we don't have a right triangle, because that's what the SOHCAHTOA works on. It works on a right triangle. So what I'm going to do, and what I want you to do also, is bring down a dotted line from that point, and also a dotted line that goes back to the origin. And now you can see a right triangle. The right triangle is located in quadrant 2, and we're going to count this now as our theta angle, but I'm going to put a little point next to it and call it theta prime. We moved it into that area because that's where the right triangle is. Now this angle right here is called a reference angle. We're going to talk about reference angles on another slide, so I'll get to that definition in a minute. Just know that this is a reference angle, this one right here. Now, as far as the triangle goes, I can figure out my sides, especially when it's on a graph. It makes it easy for me. I'm going to put negative 3 at the bottom. Now, could a triangle have a side length of negative 3? No. So technically, that just has a length of 3. But why would I put a negative there? Because it's showing direction. That's all it's doing. It's right here. It's telling me it's 3 units, but it's telling me to go in the negative direction. So this means it's a negative 3 direction. This is a positive 4 direction because we're on our graph. If I want to find my hypotenuse, I would just do 3 squared plus 4 squared equals c squared. This is going to be 25 equals c squared, and you're going to get c as 5. So your hypotenuse is going to be a 5. Now, notice up here, I just did positive 3 squared because that's the length. I could have done negative 3 squared, but I've still gotten a positive 9. Yeah, so it wouldn't have mattered. You could do negative 3 squared or positive 3 squared. You'll get the same answer. All right, now we want to find the sine of theta, the cosine of theta, and the tangent of theta. We want to find those 3 values or fractions. Sine would be SOH, S-O-H, opposite over hypotenuse. Here's your theta. Opposites 4, hypotenuse 5, so 4/5. Anybody remember what we know that has to be true about the sine? Okay, we know it's opposite over hypotenuse, right? But what do we know about its value? Has to be less than 1. Now, it could also equal 1. There are a few spots where 1 is going to be the sine. But normally, it's got to be less than 1 because the bigger number, the hypotenuse, will always be on the bottom. It means your fraction will never be an improper fraction. That means it's always going to be less than 1. So just remember that for sine. Cosine. Adjacent is negative 3, and your hypotenuse is 5. So negative 3/5. Could be a negative. between 0 and -1 also, if it's in a negative direction. And then tangent is going to be my opposite 4 over my adjacent -3. So 4 over -3, or just -4/3 would be your tangent. Now I need you to find this paper. It was a present that I gave you. It was the chart. Find your trig chart. I gave you a present. I said you're probably going to want this even when you're in calculus, if you're going into calculus, because a lot of them come back to get this chart. So find this chart. Okay, I'm going to bring up a unit circle on one earlier one that we did in our notes. And do we remember on this unit circle the coordinates that the sign represented? I heard somebody say it. It's the y-coordinate. The y-coordinate. Because if I was to bring a triangle straight down here, my opposite side is the y value, the value that's up and down. The cosine was the x value, because the cosine was the adjacent side. It was the x-axis. Now take a look at your chart, and above the sine column, put a little y up above the sine, so you remember that that's your y value on the unit circle. Above cosine, put the x value. You know that all your x coordinates are going to be your cosine. What would I put above tangent? Do you remember? The y over x. Do you remember the identity that said tangent is sine over cosine? Well, that's the same thing. Sine is y, cosine is x, so it's got to be y over x. Now we've got our 3 reciprocal ones. Cotangent, we're going to put for cotangent x over y. We're switching those two around. Those are reciprocals of each other. For secant, we're going to put 1 over x, because those two are reciprocals of each other. Cosine with secant. There's got to be one co in there somewhere. There's your cosine with your secant. And now you have a cosecant, which is 1 over y, which matches up with your sine. So put 1 over y over the last column, 1 over x over secant. Okay, now go to your side of your circle. To get to quadrant 1, you need 2 positive numbers. That means in this quadrant, your sine is a positive value, because your y is a positive number. Your cosine is also a positive value, because your x is a positive number. What's a positive divided by a positive? Positive. Tangent is also a positive value. In quadrant 1, your trig functions will all be positive. You'll have no negative function. But if you look at your chart, there are negatives on here. So not all of these angles are from quadrant 1. Some of them are in different quadrants. So if we get to quadrant 2, we would need a negative value and then a positive value. So a negative, then we need a positive. So that means my sine is my y value. It's going to be a positive amount. My cosine is the x value. It's going to be a negative amount. My tangent is sine divided by cosine. What's a positive divided by a negative? It's a negative amount. Let's double check this on the one we just did. What quadrant am I in this problem? Quadrant 2. Was my sine positive? Was my tangent negative? Was my cosine negative? Yeah, that happened because I was in quadrant 2. That's why that happened. So all of these are the right signs because I was in quadrant 2. Let's go down to quadrant 3. Yep. Yeah. All right, so quadrant 3, we need 2 negatives. So that means your sine is negative, your cosine is negative, and what's a negative divided by a negative? Positive. Your tangent, when there's 2 negatives, will be a positive value. You're never going to have a quadrant where they're all negative, because a negative divided by a negative will always give you a positive value. And then to get into the last column, you need a positive first, then a negative. So your sine is your y value. That's going to be negative. Your cosine is your x value. That's going to be positive. And what's a negative divided by a positive? Tangent is going to be negative. So that's going to come in handy on some of the problems on your homework, because they're going to give you clues. They're going to say if cosine is negative and tangent is positive, what quadrant are you going to put your triangle in? So you look at this little chart and you say, okay, here's my cosine negative, here's my tangent positive, I know my triangle's in quadrant 3. So you can use this information to help draw the triangle that you're going to need to get your sine, cosine, or tangent for. All right, let's go back to this one. Here's what I was talking about. Here's some 2 clues. Okay, 2 clues. Let me just make this a little smaller so I can move it up. You can see it a little better. Now, tangent is negative 5/4. Okay, so let me write that over here. Tangent of theta is negative 5/4. It also tells me, that's one clue, it also tells me cosine is greater than 0. So does that tell me what quadrant I'm in right now? Tangent's negative 5/4, but it's negative. Cosine is greater than 0. What does that mean? That means cosine is what? Positive. Greater than 0 means it's positive. So what quadrant, looking back on your unit circle now, has a negative tangent and a positive cosine? Quadrant 4. So now I know exactly where I'm going to be drawing my triangle at. It's going to be in quadrant 4. But how do I know the sides and stuff? Well, look at this clue right here. What does tangent represent to us? Opposite over adjacent. So I know my opposite side is a 5, my adjacent is a 4, and I know I'm going to be in quadrant 4. So adjacent is always on the x-axis. So I'm going to draw a 4 on my x-axis. My opposite side is always my y-axis. So I'm going to go down 5 because I know I'm in quadrant 4. So which side is going to get my negative value? The 5 is, it's going down. The 4 is a positive value. And then I'm going to connect my origin and my last side there. So I have my triangle. Here's my theta. It's always the angle that is next to the origin. So you're always going to be using the angle next to the origin. Here's your positive 4, which is my adjacent. And here's a negative 5, which is my opposite. It's going downward, so it has to be a negative 5. That's the direction. Doesn't mean it's a negative distance. It's just a direction of negative 5. Now, to get my hypotenuse, we're going to do 4 squared plus 5 squared equals c squared. I could do negative 5 squared. It'll still work. You're going to end up with 16 and 25, which gives you 41. And so you square root both sides. So you're going to get radical 41. Radical 41. And then now we have enough information to get the 2 trig functions that they're asking for. They're asking us to find the sine of theta and the secant of theta. Who can help me find the sine? What would my sine be? Okay, so what are the numbers? Negative 5 over radical 41. Now, I could have made that a decimal, which would be about 6.4. But whether you make it a decimal or a radical, you can't leave it on the bottom. So we need to get rid of it off the bottom. Let's multiply here by radical 41 on both sides. Negative 5 radical 41 over 41. Now, you could make that a big decimal, and it'll still be the same value. Just easy to grade these two if you leave it in that format. Now, what 2 sides does secant represent? What over what would be secant? Hypotenuse over adjacent, because it's the reciprocal of cosine, CAH. So it's got to be HA, right? Hypotenuse, adjacent. So hypotenuse over adjacent is going to be radical 41. That's nice that one's on top. And adjacent would be my positive 4. So there's your secant. Secant would be radical 41 over 4. You already got that? I keep moving back and forth. All right, so you've got your 2 clues that they gave you. Tangent was negative, cosine positive, so I know I'm in quadrant 4. I got 2 sides of the triangle. I got opposite adjacent. I use Pythagorean theorem to find hypotenuse. And then you can find any trig functions that you want. Any one that they give you, you can find it. All right, let's get to, these are on your chart. Get your chart and your unit circle out. Cosine at 0. 0 radians. Find 0 radians on your chart and find the cosine. Cosine of 0 radians is 1. Okay, let's prove it. So go back to the unit circle side. What x and y coordinate is 0 degrees or 0 radians? What coordinate do you see there? 1, 0. Do you see that coordinate? What's my x value? 1. There's your cosine, is always your x value. Okay, at this coordinate, at 0, what would my tangent be? 0 divided by 1. Remember, y divided by x. What's 0 divided by 1? 0 is my tangent. Is that what it says on the chart? Yes, tangent of 0 is 0. Find pi over 2 on your circle and tell me what the x and y coordinate is. It's 0, 1. So what would my x coordinate be? 0 this time for cosine. You can always double check it with the chart on the other side. It should say pi over 2. It should say cosine of 0. And what would the tangent be? What's 1 divided by 0? Undefined. You're right. You cannot divide by a 0. You cannot have the 0 on the bottom. Look at your chart. Does it say undefined for tangent? If you go to the pi over 2 and you go to tangent, does it say undefined? Yeah, because it knows you can't divide by 0. Now, cosine of pi. Look on your circle, and where is pi located? Negative 1, 0 is right. So what's my x value? Negative 1, that's going to be my cosine, negative 1. You could even test that on your chart. It'll say cosine of pi, you'll have a negative 1 there. What's the tangent at pi? What is 0 divided by negative 1? That's 0. Good. 0 on top means you're going to have a 0 no matter what. 0 over something is 0. 3 pi over 2 is at the very bottom of your circle. So yeah, it's 0, negative 1. My x value is 0. Now, look at these values. Remember I told you cosine always has to be between 0 and 1? And it could also be 0 or 1 if you're on these axes. But it can never be greater than 1 because it can't. The hypotenuse is on the bottom. But you can always be somewhere between them. Now, it could also be between 0 and negative 1 because that's still a 0 point something, positive or negative. What about the tangent here? What's negative 1 divided by 0? Undefined. Yeah, that's undefined also. You can't divide by 0. So those are just the angles that are on the x and y axis. Just wanted to look at those really quick. Okay, I told you that we were going to talk about reference angles. Said I was going to give you the definition. Here's the definition of a reference angle. It's the acute angle made by the terminal side. I messed it up. I tried to fix it. I tried to be all fancy, and I messed it up. Oops. So let me fix it here. By terminal side of the angle. And the horizontal axis. That's what it was supposed to be. Okay, so it's the acute angle made by the terminal side of the angle and the horizontal or x-axis. Now, in our example number 1, it looked like this. Okay, it looked like we had the point. If you remember the very first example, we went over -3 and up 4. And this was where our angle, our theta prime was in here, because this was our reference angle. Your reference angle has to be acute. It has to be acute angle. It cannot be obtuse. It has to be acute, because what kind of angles do we have inside of a right triangle? We have a right angle and we have two what kind of angles? In every right triangle, you have a right angle and two acute angles. So your reference angle has to be an acute angle, because it's the angle that we're going to use to draw in our right triangle. So if I drew in a right triangle here, this is my acute angle inside of the right triangle. So a reference angle has to be acute because you're using that angle to draw in your right triangle. Now, what if the point was down in this quadrant, down in quadrant 3? Then it would look something like this. Here's theta, here would be theta prime right here. Because our reference angle would be this smaller angle in here. This would make my right triangle right there. So this would be theta right in here, or theta prime. So we would use that for our sine, our cosine, and our tangent. We need to use something to draw a triangle. So to draw the triangle, we're going to use what they call a reference angle to do it. And then the last case would be, what if it's in quadrant 4 down here? So if it's in quadrant 4, then your reference angle would be way down there towards the 0 degrees or 360 degrees. This way down here would be your reference angle. This little angle, you could make your right triangle right here, and you'd have a reference angle. So now you've seen an example of one in the second quadrant, one in the third quadrant, and one in the fourth quadrant. Noticing you're always going back to the x-axis to draw your triangle. So we're always taking our angle and going back to the x-axis so that we can draw in our right triangle. Do we have the top two done?
Okay.
So I can move it up. I know the dot. Oh, you did the bottom one?
Wow.
Okay. We're going to get the top one so I can move it up. Because we got 3 examples, A, B, and C. Find the reference angle theta prime for 300 degrees. So if you were to go around our unit circle to 300 degrees, that'd be like right here. What would my reference angle be? What would get me the rest of the way to 360? Because I want to get back to the x-axis. 60, because what I would do is I would take 360 and subtract 300, and that would give me a 60-degree reference angle. 60-degree reference angle would be what's left over to get me back up to the x-axis. I was almost all the way back to the x-axis, but I still needed 60 more degrees to get there. So what do you think the reference angle for 2.3 is? Reference angle for 2.3.
Wait, that is
Ooh, what is it in? It doesn't say degrees, does it? What's the only other option? Radians. So if it doesn't say anything, it's in radians. So 2.3 radians. Do I want to go to this side of my circle or this side of my circle? Where would 2.3 radians be? The first part here? Because what's half a circle? Isn't that pi?
Yeah.
And how much is pi? 3.14 radians. So remember, I don't know if you remember this from the very first day, I showed you a little video that 1 radian is about 57 degrees. So 2 radians would be about 114. So about right here, 57, then a 114. So 2.3 radians is right in this area. So we would need to get down to pi to our right triangle. So what we're going to do is we're going to take 3.14 and subtract 2.3 to see what would be left to get me up to 3.14. And when you subtract that, you get 0.84 radians. What is the reference angle for negative 135 degrees? Negative 135. You would start here, and you would end about there. My reference angle would be this angle in right in this area. It's going to be 180, because wouldn't half the circle be 180?
Yes.
Subtract 135 from it to see what would be left over here. That's going to give me 45. Would it be positive or negative? No. Reference angles are always positive. Because think about this. If I have a triangle, and I got 3 angles in a triangle, could any one of those be negative? No. You can't have a negative. If you're opening up, it's a positive angle, no matter what. So when I'm drawing in a triangle right here, it's got to be a positive angle right there because I'm making it into a triangle. So your reference angles are always positive angles, no matter what. Positive amount. All right. Grab your chart. First one that can tell me cosine of 4 pi over 3 wins. On your mark, go. Cosine 4 pi over 3. Go. Wow, that was pretty fast. Negative 1/2. I didn't say they won anything. I just said they won. Negative 1/2 is correct. Now you guys need to find that. Where is 4 pi over 3?
40 degrees.
It's 240 degrees. You go across the cosine, you'll see negative 1/2. If you were to go to your circle and go down to 240 degrees, you would see the x-coordinate being negative 1/2. Because that's what your cosine would be. Okay, tangent of negative 210. Go. Tangent of negative 210. Who has it? What is it? No. No. Negative radical 3 over 3.
Where are you at?
Now, it's not why you think it is. Here's what I had people doing earlier today. They would go down to 210, and they would go over to tangent, and it says radical 3 over 3. And they're thinking, well, it's a negative 210, so it must be a negative radical 3 over 3. They got lucky. That was the right answer, but that's the wrong reasoning to get there. You do that on other angles, you're going to miss them. The reason it's negative radical 3 over 3 is because if I took negative 210 and I added a circle, you remember what we called this special angles called coterminal angles? They were angles that were in the same place, so they had the same sine, the same cosine, the same tangent.
Yeah.
Negative 210, if I added a rotation to it, so let me draw you a little visual.
Oh.
Negative 210 would be right here. What would be my positive angle that gets me to there? That's what's on your chart. The positive angles are on your chart, not the negative angles. What is negative 210 plus 360? It's 150 degrees. Look at 150 on your chart. What is tangent? Negative radical 3 over 3. That's why it's negative radical 3 over 3. Not because you take the 210 and make it negative. You've got to use a circle. Now, if it's in radians, I'm not going to use 360. I'm going to use what? What's a circle in radians? 2 pi's. 1 pi's half. 2 pi's is the whole circle. So anybody think they can figure this one out?
No.
Use your chart. On your mark, say go. Come on. You got this. You got this. Come on. I know you can find it. I know you can. I know you got it. Come on. What would it be? Somebody give me the answer. Cosecant of 11 pi over 4. It's trying. I see the wheels turning. Come on, what do we got? Tyler Martinez had it like that. Seriously, he did. Not your brother, he had it like that. He had it really quick. Okay, so what do we got? Nobody?
Hold on, wait, you have more time.
Okay, let me just give you a hint.
Radical 2.
Radical 2. Justin, great. Got it.
You didn't get it.
This is why it's radical 2. I'm going to subtract a circle.
Do that.
Why would I use 8 pi over 4 as a circle? Doesn't that reduce the 2 pi? Doesn't that have a common denominator? Those are two things I need. I need 2 pi and I need a common denominator. So that's actually going to equal 3 pi over 4. 3 pi over 4 and 11 pi over 4 are coterminal angles. They're the same values. So if you go to 3 pi over 4, you're also getting the values for 11 pi over 4. Now if you go, try 3 pi over 4, go all the way across. What do you see? You see radical 2. Radical 2 for cosecant.
I didn't do that.
You got it right there. You get it? Oh, you converted it to degrees. That's fine too. That works. Yep. You went to degrees, then you what, subtracted the circle or something from it? Good. All right. Moving on.
Radical 2 over 2, radical 2.
Just radical 2. That's all it was. I went to 3 pi over 4 on my chart. 3 pi over 4 on the chart, not the circle. Go to the chart side. Go down to 3 pi over 4. And go across all the way to the end. 3 pi over 4, all the way to the end, you'll see radical 2. All right, we got to get to the last one here so we have enough time to finish. We're in quadrant 2. It's telling us the clues. Quadrant 2, and the sign is 1/3. So the sign is 1/3, which means we have an opposite side of 1 and a hypotenuse of 3. That's giving us two sides of the triangle. How do I find my third side? Two sides, third side, a squared plus b squared equals c squared. So help me set it up. 1 squared plus b squared, we don't know the adjacent, equals 3 squared. So we're going to get 1 plus b squared equals 9. B squared is 8. Square root both sides. B is going to be 2 radical 2. Now let's draw the triangle. We know that my adjacent side is 2 radical 2. This is the adjacent. That's going to be on my x-axis. I know I'm in quadrant 2. So I'm going to come over my 2 radical 2, which is almost 3, but not quite. Because radical 9 would be 3. We got radical 8. So it's probably like 2.8. So somewhere close to 3. My opposite side tells me to go up 1. So I'm just going to go up 1. And then I'm going to draw in my triangle there. So it's a small triangle. And you've got a 1, you've got a 3, and you've got a negative 2 radical 2. Why is that negative? Direction. It's going to the left. So it's got to be negative 2 radical 2. With those three amounts, we can now find the cosine and the tangent. Cosine of theta. Help me find cosine. Theta is always next to the origin. Always going to be right in there, that little angle next to the origin. Okay, so it's going to be a 1. No, it's not. We want cosine. We want adjacent, don't we? So negative radical 2, negative 2 radical 2 over 3. That's your cosine. We want tangent. This time we want the opposite first, right? We want the OA, TOA. So we want the 1 over the negative 2 radical 2. Can't leave it like that, though. So let's get rid of the radical 2 from the bottom. So I'm going to get a radical 2 on top. And what would come out on the bottom? Negative 4. Close. You've got radical 2 times radical 2 is 2, and then your negative 2 times your 2 would be a negative 4. So that would be your tangent. So you're going to get problems on the homework tonight. You got page 166, 1 through 27 on, where they're going to give you some clues. You got to find out what quadrant to put your triangle in, and then draw in the 3 sides and solve it. The last little page here are just 3 on a calculator. So grab a calculator. If you don't have one, just watch closely and make sure you can get it next time. How do I put in cotangent of 410 in a calculator?
1 divided by the tangent of 410.
Good. 1 divided by the tangent of 410. Okay, now I have to be careful on this one to make sure I'm in what mode? Got to be in degree mode, because it says 410 degrees. So 1 divided by tan of 410. Okay, now if I expanded it out, which we usually do with on the calculator, 8391 would be a good 4-digit for you, 4 decimals. What about the sine of -7? Okay, so it's just sine of -7. You don't have to do any 1 divided bys. So sine of -7. And you should get negative 0.6570.
What?
Does it say degrees?
That's sine of
Does it say 7 degrees?
say
Oh.
7
It just says 7. It means radians. If it doesn't say a degree symbol, you're going to go to radian. You got to go to radian mode. So if you go to radian mode and you do sine of -7, you should get this answer in radians.
Yeah.
How do I change it from there to range?
You got to go to the DRG button top.
Oh.
Okay, what about the third one here? Secant of pi over 9. Now, I really like this kind of calculator. The Texas Instruments TI-30X, because I can put that directly in. I can put 1 divided by cosine. I can put pi/9, my divided sign, and it'll give me my answer. Some of your other calculators, you have to do the pi divided by 9 first. Then you got to do all kinds of stuff. With this calculator, you're going to put it straight in. 1 divided by cosine of pi divided by 9 equals, you should get 1.0642.
Are you still in degree mode?
You should be in radian mode again. The last two are both radian. It's only degree mode if you see a degree. If you don't see anything, it's always radians. They will give you degrees, then you know it's in degree mode. All right, that is it for 1-4.